It doesn't take a lot of time online, or maybe even talking with some of your family and friends, to find people who don't believe that humans can impact the climate in any way. I'm Amanda San Miguel, and today I'm going to go over some of the evidence that we have scientifically of how we know that humans can impact the climate and are doing so. One thing that you often hear people talk about is they say that the climate is always changing. That's absolutely true. This particular graph is from an ice core that was taken from Antarctica, and it goes back 400,000 years. The bottom part shows the temperature change over that period of time. Now the orange line that goes across shows relative to today's temperature. So that's today. So you can absolutely see today's not been the warmest it's ever been. It's also not been the coldest. The Earth has gone through many cycles, and this is only 400,000 years. So this isn't even close to the complete history of the Earth. However, humans weren't always present during all of this time here. So let's talk a little bit more about what some of the natural variations that lead to changes in climate. The most famous of these are called Milankovitch cycles, and I'm going to go over some of these of the aspects of this. The first is eccentricity, which talks about how circular or elliptical the Earth's orbit is around the sun. Now this impacts how close the Earth gets to the sun, which ultimately impacts how much radiation reaches the Earth. The second is called the precession. You can think of this as if the Earth was a top, since the axis is actually not straight up and down. If you think of a top when it's about to fall and it kind of does this wobble thing around, well, the Earth does that over a period of time, and that impacts how the sun gets distributed over the Earth, and it also impacts whenever the Earth is actually closest to the sun, which part of the Earth is getting the most radiation. Now the third part of the Milankovitch cycles is called the obliquity, or the tilt. Now this is the axis. Right now the Earth is tilted at 23.5 degrees, but that varies a little bit over time. So that impacts how the sunlight gets distributed over the Earth, which impacts, you have a lot more, the way that our land mass is distributed, we have a lot more land mass on the northern part of the hemisphere versus the southern part of the hemisphere. So whether the ocean is getting heated more or the land getting heated more, and how much gets reflected back, it impacts that. So the short thing is that these cycles absolutely do have an impact on climate, but if you look at the time scales, the shortest one of these time scales is around 24,000 years. So that time scales are too long to explain what's been happening in the recent past. So let's look a little bit more about the recent trends. Now these graphs have been taken from the IPCC's Climate Change 2014 Synthesis Report, and it shows the carbon dioxide and methane concentrations over the last 10,000 years. You can see that things were pretty steady until very close to year zero, which is around where we are now, and that was blown up in those little insets there. You can see since around 1800, both the emissions of carbon dioxide and methane have been increasing quite a bit. Now, what's happened in that time frame that's caused that, since we had this pretty steady concentrations over the last 10,000 years? This happens to coincide quite nicely with the Industrial Revolution. The time frames are a little bit contentious, but generally the late 18th century and the early 19th century is when it's been accepted that the Industrial Revolution occurred. The Industrial Revolution completely changed human society. This is when steam power really came into fruition, and you went from primarily human labor to machines either completely taking the place of or augmenting human labor at that time. And it really put us on the path to the energy-intensive society that we're at today. So let's talk a little bit about some of the evidence that we have for humans impacting climate change since the Industrial Revolution. Now the first is modeling. Because we have very good data over the last, most recent time period, we can use models to try to recreate the trends that we've seen in temperatures to see what factors go into it and if we can figure out what the causes were. So this has been done quite a bit. And this is also from the IPCC's report. Now on this graph, the red and the blue lines show the models and the black shows the actual observations. So what scientists have done is they said, if we only include the natural variabilities, what's happened with the planet, the inputs from the sun, taking humans out of the equation, can we replicate what's happened with the actual temperatures we've seen? And you can see that the model underpredicts. There's this gap right here where the model can't explain this increase in temperature that we see. But when they include both the greenhouse gas and the natural sources, the model fits quite nicely, and it almost exactly replicates what we've seen. So we know that greenhouse gases have something to do with the increases in temperatures that we've seen. But how do we know that the greenhouse gases actually came from humans? So next we have to go to looking at carbon isotopes. So carbon isotopes are different forms of an element that have the same amount of protons, but they have different amounts of neutrons. And a lot of these are found very naturally in nature. So for carbon, there's 3 isotopes that are found. The first 2, carbon-12 and carbon-13, they're both stable. That means that they don't degrade over time. Plants prefer to take in carbon-12, or they prefer to take in carbon dioxide that's made with carbon-12, and this will be important in just a minute. Carbon-14 is radioactive. It has a half-life of 5,700 years. So that means it degrades over a long period of time. So, as scientists, if we were to say, if fossil fuels are the source of CO2, what would we expect to see? First of all, we would expect to see a depleted carbon-14 because fossil fuels have been buried underground for millions of years, and the half-life is only 5,700 years. That means that carbon-14 has had a time to completely decay, and you would see very little, if any, carbon-14 in the amount of greenhouse gases that we're releasing. We would also expect to see lower amounts of carbon-13. As I mentioned, plants prefer to take in carbon-12, and when you think about it, fossil fuels are really just really old plants that have decayed, so they would show the same carbon signature as the plants. When you look at the actual data, both the carbon-13 and the carbon-14, it says the delta carbon-13 on the left axis, delta carbon-14 on the right axis. You do see that over time the atmospheric concentration of both of these has gone down, which indicates that fossil fuels are the source of the increased carbon dioxide in the atmosphere. So really in conclusion, when people ask, how do we know that humans are causing this? You can explain that natural variability absolutely does change the climate, and it has changed the climate for most of the Earth's history, but it can't explain the short-term recent trends that we've seen in increases. Also, carbon isotope puts a fingerprint on the type of carbon dioxide that's being released into the atmosphere. So by taking these samples, we can figure out what the sources were, and this definitely points to fossil fuels. I'd like to open the floor for questions now.
This is awesome. Can you send this to us? I love this. I'd like some people who are just like ridiculously dumb at home.
I think the aim is that all of these
They'll all get to
modules
air.ri
and
site.
the videos will, you can look at it just in terms of the slides or look at it in the videos on the website.
Great work.
So the videos will have your comments referring everyone back home to being done.
Edit that.
I'll just send them to the slides. Wait, so what was like the source for the data? Like especially like the charts that we were looking at where it didn't explain it, and then
Oh, that was from the IPCC, the Intergovernmental Panel on Climate Change, and they release reports. I don't know if it's a regular frequency, but every several years, and they have hundreds of climate scientists from all over the world that contribute to that. So I don't know those particular graphs. I don't know which scientists work on it, but it's a collaboration between the top climate scientists in the world.
We have sinks of some of the fossil fuel carbon that we put into the air ends up in other places. What are some ways that we might know which sink it's ending up in, and does that affect that we were looking at carbon signatures? So does that affect what we see if some of it cycles through one or another sink?
I don't know. I'm not familiar enough with the measuring the different isotopes, and other than I know that they do it in the atmosphere and they do it in things like rocks, right, for carbon dating. But one of the biggest sinks right now is the oceans. And you do have the oceans acidifying over time, but I don't know if the isotope, I mean, I would presume they make it in there, but I don't know how you would measure that in the oceans. Like, I don't know if you would use the organisms in the oceans as a proxy, or if you can measure it directly in the water. I'm not really sure. if there is a proxy in the water. But that's where most of the biggest carbon sink is.
Thanks, Amanda.